Okay, hello. Let's go through this problem. This is chapter 5, problem 17, and I've sort of drawn a picture over here. This is the climber right here, and she's holding on to this rope. So there's tension, um, and there's also the force of her legs. Now she's pushing against the rock here, and I know these angles are not really drawn to scale. But that means that the rock face here is pushing back on her, so there's a force FL. All right, so what we're going to do first, and this is part A, is we need to find the tension, find tension in the rope, and we want the force FL that she's exerting on the rock face. Okay, all right, so to do that, we're going to use the fact that she's not moving, so that means that the sum of all the forces must add up to 0. So let's do the forces in the x direction. And for that, I'm always, and you should always do this yourself, is write down a little coordinate system to tell you which direction coordinates point in and which direction is positive and negative. So this is x and this is y, and this is actually plus x and plus y. So downward forces in y would be negative, and forces that go this way, right, will be negative x. Okay, so that tells me what to do as far as signs goes. All right, so first I'm going to do the f direction. So the sum of all the forces in the x direction must equal 0. So what are the forces in the x direction? All right, well, we have this FL has a component in the x direction that's given by the cosine, right? So the FL times the cosine of 15 degrees, right? Because the cosine is this adjacent side over the hypotenuse, right? So we know that the cosine of 15 degrees here from this guy is going to be adjacent, which is the FL sub x that we want, over the hypotenuse FL, right? So the hypotenuse is this guy, because you think about drawing this, this perpendicular here with the right triangle. Okay, so so now I know FLX, which is what I want. So right, FLX is going to be FL times cosine of 15. What direction is it in? Positive or negative? It is in the positive direction, right? It goes up this way. So we go plus, we have FL, and that's just the magnitude of FL, of course, cosine of 15 degrees. Okay, I hope that looks like a 15. All right, and then what else do we have in the x direction? Well, we have a component of the tension in the x direction, right? So if I were going to drop a perpendicular here with my right triangle, then I can see that this component is actually not the cosine that I want, because it's the opposite side. So that means that the sine of 30 degrees here is what? Well, opposite side, which is t sub x, over hypotenuse, which is t. So just think of that t force as going all the way up here, right? It's not really drawn that way, but that's what you should imagine. Okay, and so that means that I need to put t sine theta to get my t sub x, right? Now, which direction is that? It's negative, right? You can see that that would be a negative. To add up, you'd have to put the arrow this way, right? Okay, so minus t sub x, or sorry, just t sine of 30 degrees. Okay, so that's all equal to 0. So that tells me what t is. Okay, so, or what FL. How about I solve for FL? So we have FL is equal to t sine of 30 degrees over cosine of 15 degrees, right? That's what FL is. All right, well, let's continue, because we don't have enough equations here to solve for both T and FL, right? So I need another one, so we'll do the sum of the forces in the y direction must also be 0, because there's no acceleration in the y direction either. Not moving, right, or not accelerating. Could be moving at constant speed, is not in this case, and still have the forces sum to 0, right? But there's no acceleration. All right, so this has to add to 0, and now we have to figure out what all the forces are in the y direction. And what I've left off this drawing is, of course, the weight of the mountain climber, which is here, which is mg, right? Straight down in the negative y direction. So why don't I start with that? Minus mg, And now I have a component of FL in that direction, but it's positive. And that's going to be, remember, so sine of 15 degrees is equal to FLY over FL. So FLY is FL times sine, and that's in the positive direction, so plus FL sine of 15 degrees, okay? And then we have also a component in the positive y direction due to the tension. As you can see here, that's going to be the adjacent, right? So here's the angle, so the adjacent, so that's going to be cosine of 30 degrees is equal to the adjacent, which is the t sub y, right? So really, think of this arrow as being all the way up here. It really should be drawn that way. Okay, so then we have the cosine of 30 is going to be the adjacent, which is t sub y over t. Okay, so t sub y is t cosine, and it's in the positive direction. Okay, so plus t cosine of 30 degrees, right? Okay. All right, so now we could substitute it in here for FL, right? Because we have FL in terms of t. So why don't we do that? So we have 0 is equal to minus mg, and then plus FL, which is t sine of 15 degrees. And, oh, sorry, so I'm putting this 15 degrees there first, and then we have these guys. Okay, times the sine of 30 degrees over the cosine of 15 degrees, right? So we put everything in here. All right, now, and then we have also t here. So t cosine of 30 degrees. Well, notice this means I can solve for t here, or at least pull t out of these terms. Okay, so I'm going to put mg on one side, so I have mg over here, and now I'm going to put t by itself and solve here. So I have the sine over the cosine, which is the tangent. Tangent of 15 degrees times sine of 30 degrees. I just didn't want to keep holding this around, carrying this thing around. All right, plus cosine of 30 degrees. Okay, so that means that I can solve for t. So t is mg over this big long thing, tangent of 15 degrees, sine of 30 degrees, plus cosine of 30 degrees. Okay, so let's plug all that in, put numbers in. I always wait to put in numbers. The angles I didn't, because I didn't want to rename these, theta and phi or something, the angles. So I just kept the angles there. But usually I'll wait until I need to calculate something before I put numbers in. Don't drag numbers around in algebra. That'll just guaranteed to make you make a mistake. Okay, so what is our weight is our mass is 52 kilograms. So we have 52 kilograms, and always put your units in when you're doing calculations, times 9.8 meters per second squared over something that's completely unitless. Tangent 15 degrees, sine of 30 degrees plus the cosine of 30 degrees. Okay, let's check our units. Well, kilograms meters per second squared is, of course, newtons, so we're good. Okay, always check your units. All right, I'm going to plug in. Oh, I just realized that I was writing 30 everywhere instead of 31 degrees. The actual angle is 31 up here, not 30. Okay, excuse me for that. So I'm just going to sort of replace it everywhere, okay? So yeah, I should have realized that was not correct. Okay, there we go. 31. Okay, 31. There we go. Yeah, kind of annoying, right? 31 is so close to 30 that the answer will only be slightly different, but enough to be annoying. So we'll just make sure that we have 31 everywhere. So is it 31 in the problem, and I just somehow read it as 30? Easy mistake to make, so don't do as I've done. Okay. 31, 31, 31, and 31, and let me plug into the calculator. 512 newtons. Okay, and I'm not paying any attention to significant figures right this second. Okay, just want to show you how to get through this. Okay, so now we have that, and notice that we also now know FL because all we have to do is plug in because we have the tension, right? So let's do that. So we have FL is equal to T, which is 512 newtons, and then times the sine of 31 degrees over the cosine of 15 degrees. Okay. Okay, so that gives us 273 newtons. Now that's slightly off from what your book got, but that's just a calculator issue, most likely. Okay, and they did it in the opposite order too, so that may have contributed. Okay, all right, so here's the two answers. All right, so the next part of the question, B, is asking about the minimum friction. Right, it says, what is the minimum coefficient of friction? Sorry, the minimum coefficient of friction between her shoes and the cliff to keep her up. Okay. So remember, the friction is going to act up in this direction, right? So this is your frictional force. Okay, and remember that mu s, the static friction, times n, right, is our frictional force, right? So times the normal force. Well, what is the normal force going to be here? It's going to be the x component of this force. So now think of her legs as pushing on the wall, right? And so there's that normal force, is that force that is perpendicular, i.e. normal to the surface, and that is going to be the x component of her leg force, right? So that'll be FL cosine of 15, right? So we'll write that down. So we have mu s times FL, which we already know, times the cosine of 15 degrees, right? Now, this whole thing better be greater than or equal to the force pushing to you know, the downward force, right? Well, think of it this way, not really, this is compensating for gravity, right? So this is partly compensating for gravity along with the tension. And so we need this to be greater than or equal to that force that is needed to keep her up. Okay, and what is that? That's the y component of FLY, right? So that's FL sine of 15 degrees. All right, so we know that's the case. Now notice that FL is just going to cancel right out of that, and I do get an equation for the minimum, which is going to be when this is equal, right? Not greater than equal, but just equal, but I'll write that down in a second. Sine 15 degrees over cosine of 15 degrees. Okay, and so the minimum is mu s equal sine 15 degrees or over cosine 15 degrees, which of course is just the tangent of 15 degrees, which is just 0.268 to 3 sig figs, right? So notice that 3 sig figs is what we need because the problem statement had, you know, like for instance, her weight as 52.0 kilograms, right? So we have 3 sig figs here, we're good. We have 3 sig figs here, we're good. Just happened a way that this didn't need to round or anything. This I didn't really need to round either. This one I did round because it was 2, 6, 7, 9, etc. So I rounded to 3 sig figs here, and this is the minimum coefficient of friction. Otherwise, her feet will slip, and she will not be held up, right? So you can imagine, you know, for slippery rock, that she wouldn't be able to brace herself against the rock with that with her feet. Okay, well, I hope this helps. Good luck.